Bismillahirrahmanirrahim. Assalamu alaikum. Exercise 13.1, question number 1. In this question, two sides of a triangle measure 10 centimeter and 15 centimeter. Which of the following measure is possible for the third side? And the four options that we have is 5 centimeter, 20 centimeter, 25 centimeter, and 30 centimeter. We will use the theorem which says that sum of two sides of a triangle is greater than the third side. So this is the key factor behind it. Let's check one by one. Let's first of all check 5. If we add the two sides of a triangle, the sum is greater than the third side, then it's okay. Otherwise, we will say that this this measurement is not possible. As we can see that 10 plus 5 is equal to 15, which is equal to 15, which is the third side. So this 5 centimeter is not possible. And if we look at option number C, same goes here. 10 plus 15 is 25, which is equal to the third side. So 25 is not possible. Similarly, option number D, 10 plus 15 is 25, which is less than the third side, 30. So this is also not possible. But when we look at option number B, what happens in this is that 10 plus 15 is 25, which is greater than the third side, 20. And 10 plus 20, if we look at the second option, 10 plus 20, which is 30, it is greater than the third side, 25. And if we look at the third option, 20 plus 15, it is 35, which is greater than the third measurement, 25. So 20 centimeter. This option number B, 20 centimeter, is the possible third side of a triangle whose two sides are 10 centimeter and 15 centimeter. Now look at the statement of question number 2. It says that O is an interior point of triangle. Show that measure OA plus measure OB plus measure OC is greater than half of measure AB plus measure BC plus measure CA. So O is some interior point in this triangle ABC, and if we look at the triangle AOB in this big triangle, a part of the triangle OAB, we can say that sum of two sides is greater than the third side. So measure OA plus measure OB will be greater than the third side AB. And if we look at the triangle, OBC, this second triangle, in this triangle we apply the same rule that sum of two sides is greater than the third side, then we get the result that measure OB plus measure OC is greater than BC. This is result number 2. And if we look at the third triangle here, OAC, in this we can apply the same rule that the sum of the two sides will be greater than the third side. So measure OC plus OA is greater than AC, and this is result number 3. Now, by adding all these results, result number 1, 2, and 3, we get measure OA plus measure OB plus measure OB plus measure OC plus measure OC plus measure OC. By adding the left hand sides, we will be adding the right hand side. So this left hand side will be greater than the right hand side, which is the sum of all the right hand sides of 1, 2, and 3 is measure AB plus BC plus AC. And it becomes 2 times OA, 2 times OB, 2 times OC is greater than the whole right hand side, and 2 we take common, and then we shift it on the other side, and we get the our desired result, that is measure OA plus OB plus OC is greater than half of AB plus BC plus AC. So in this way we have proved it. Now look at question number 3. In this question, in this triangle ABC, measure angle B is 70 and measure angle C is 45, and they are asking that which of the sides of the triangle is longest and which is shortest. As we can see that measure angle B is 70 and C is 45, so definitely measure angle A will be equal to 180 minus sum of these two, which becomes 65 degrees. So from these 3 measurements, we can see that measure angle B is greatest, which is 70. So its opposite side, which will be AC, this will be the greatest or the longest side. And we can see that measure angle C is shortest. It is 45 degrees. So its opposite side, AB, will be shortest. Any angle which is greater, its opposite side is always greater, and any angle which is shorter or smaller, its opposite side will also be smaller. Now question number 4, prove that in a right angle triangle, hypotenuse is longer than each of the other two sides. Now we have a right angle triangle in which measure angle B is 90 degree, and if measure angle B is 90, then measure angle A and measure angle C. Measure angle A and C both will be acute. This angle A and this angle will be acute because the sum of A and C will be 90. So measure angle A and measure angle C both will be less than 90. As we can see that measure angle B in this case is 90, it is greatest, so its opposite side AC will be the hypotenuse, and it will be the longest side. As we can see that in the figure, the side opposite to the 90 degrees always called hypotenuse, and here in this case it is AC. So if B is 90, then its opposite side AC will be hypotenuse, which is the longest side, the longest of the other two sides, which are AB and BC. So in this way we have proved it. Now come to the next exercise, which is 13.2. Question number 1, the statement is, in this figure, P is any point and AB is a line. Which of the following is the shortest distance between the point P and the line AB? And this is the diagram, and they are asking that is PL is the shortest distance, or PM is the shortest distance, or PN is the shortest distance, or PO is the shortest distance. Now according to the theorem 13.4, which says that from a point outside a line, a perpendicular is the shortest distance from that point to the line. Therefore, as we can see that perpendicular is over here 90. This PN is perpendicular to AB because it is making an angle of 90. We are having a 90 degree at N. So PN will be the shortest distance from this point P to this line AB. In question number 2, the statement is that in this figure, P is any point lying away from the line AB. Then PL will be the shortest distance if PLA is 80 degree, PLB is 100 degree, or PLA angle is 90 degree. As we have just seen that we can get a shortest distance only and only if it is perpendicular. So PL will be the shortest distance from AB if it is perpendicular to AB, and this is only possible if we have PLA is equal to, angle PLA is equal to 90 degree. So option number 3 is correct. Now we move to the next exercise, which is our review exercise 13. A few questions from that review exercise. In question number 3, now they are very simple questions. In question number 3, they say that 13 centimeter, 12 centimeter, and 5 centimeter are the lengths of a triangle, and verify that the difference of the measure of any two sides is less than the third side. So we will take the difference of all the sides one by one. 13 minus 12, which is 1, is less than third side. 13 minus 5 is 8, which is less than third side. 12 minus 5, which is 7, is less than the third side, 13. So it is proved. In the same manner, in question number 4, we are given three sides, 10, 6, and 8 centimeter, and they say that verify that the sum of the measure of any two sides is greater than the third side. Now, so difference was the smaller than the third side, and sum is greater than the third side. So one by one we will take all the sums. 10 plus 6, 16, which is less than third side, 8. 10 plus 8, which is 18, is greater than 16, is greater than 8, and 10 plus 8, which is 18, is greater than 16, and 6 plus 8 is 14, which is greater than 10. So all the sum of two sides is greater than the third sides in all the cases. All possible cases have been taken, and we have to take all possible cases. In question number 5, 3, 4, and 7 centimeter are they say that prove that 3, 4, and 7 centimeter are not the length of the triangle. Why? we have to give the reason for this. So as we add 3 plus 4, we get 7. 7 is equal to the third side. 7, it must be greater than the third side. The sum of the two sides must be greater than the third side. So according to the theorem 13.3, the sum of the measure of any two sides of a triangle which is greater than the third side, here it is not. So we can say that due to the theorem 13.3, it is not satisfying our theorem 13.3. We can say that it is not the third. It is not the measurement. These measurements are not possible in any triangle. In question number 6, 3 centimeter and 4 centimeter are the length of the two sides of a right angle triangle. Then they are asking that what should be the third side of the triangle. So as it is a right angle triangle, so we can apply Pythagoras theorem, and by Pythagoras theorem we can say base square plus perpendicular square is equal to hypotenuse square, and by taking these two lengths as base and perpendicular squares, 3 square plus 4 square, we get the hypotenuse equal to 5 centimeters. So the length of the third side is 5 centimeters. I hope all these solutions are clear. Thank you.